Hello students, today we are going to discuss about a very interesting topic, and that is energy. Now what is this energy? Well, we've studied that energy is the capacity to do work. As we do lots of activities in our daily life, and for carrying out these activities, we all need energy, right? Now the question is, where do we get this energy from? So yes, we get this energy from the food that we eat. And not only human beings, but all the living beings, they need energy for completing their vital physiological functions. For example, plants, they receive energy from the sun, which is utilized by them in the synthesis of their food. And this process is known as, come on, you've studied this in earlier classes. Yes, this is known as photosynthesis. Well, sun, it is the biggest natural source of energy. So what do you get from sun? Simple, we get energy. So let us explore some more piece of information on energy. Now in order to do some work, we need to spend some energy. So like we walk or we run, so whenever we do such activities, our energy is spent, which means that we utilize energy for accomplishing any work. Now how do we know that an object has got some energy or not? So when the object has the capability to do work, it is said that it possesses energy. Now what do you mean by work in terms of physics? We studied this in the earlier modules. So work is said to be done when there's a displacement of the object on the application of force. So energy and work are interrelated to each other. Now we all know that if a body has energy, it has the capacity for doing work. But have you ever wondered that how does an object having energy perform work? Well, if an object that possesses energy exerts force on another object, then the energy, it gets transformed from or transferred from former to later. Before we go further, we must understand the law of conservation of energy. So what does this law state? The law of conservation of energy states that energy is always conserved in the universe, and it simply changes from one form to another form. Now let's understand this by doing a simple experiment. So here we have two pieces of magnets having holes in the middle, and we pass a smooth straw through the holes in these magnets. Now we place the two like poles near to each other as I am showing you here. So in doing so, I will spend some of my muscular energy. Now what do you think? What's going to happen if we hold the like poles close to each other? Yes, so the energy will be stored between these two magnets. And now, see what happens when I set them apart, or when I set them free instead. So you see, the two magnets, they move apart from each other. Now, do you know the reason why it has happened? Yes, so it has happened because both the like poles, they exert a force of repulsion on each other. And the energy which was stored between these two like poles, it is changed into the energy of motion between the two magnets. Thus, from the above experiment, it is concluded that an object which possesses energy can do work, and the energy can change from one form to another. Now let's consider some more examples to increase our understanding of energy. So here is a book, and when I lift this book to a certain height by applying the force against the gravity, what do you say about the book after it is moved up? Yes, we say that the book acquires energy, as when we lift this book to a certain height, work is done on the book against the force of gravity. Thus, the work done against the gravitational force, it gets stored in the book as its energy. Now let's take another situation. So here is the spring, and if we keep one end of the spring fixed and stretch it from the other end, then what do you observe? Yes, we can observe that when the spring is stretched, it has gained energy by the virtue of its deformation. And this stored energy is released when we remove the applied force. Let's do one more activity. So here is a ball which is resting on the top of an inclined plane. So what do you think? Is there energy? Is there any energy in it? Yes, some energy is stored in the ball due to its height from the ground. And as I give a slight push to it, the stored energy of the ball, it gets transformed into the energy of motion. Till now, just recall all the above examples, and do you find anything common in them? Well, in all the examples that we have taken, the objects acquire capability of doing work through different means. Thus, energy possessed by an object is measured in terms of its capacity of doing work. So this is all about energy. And studying till now, what do you think? What type of quantity is the energy? Now, as energy, it only involves magnitude and not direction. So what do you think? Is energy a scalar or a vector quantity? Yes, energy is a scalar quantity as it only involves magnitude and not direction. And the unit of energy is the same as that of work, and that is joule, which is represented by capital J. So to do 1 joule of work, we need 1 joule of energy, where 1 joule of work is defined as the amount of work done when a force of 1 Newton moves the body through a distance of 1 meter in the direction of applied force. Now there are also larger units of energy besides joule. So we have kilojoules, which is represented by symbol small k and capital J, and it is equal to 1000 joules, or we can say 10 to the power 3 joules. And then we also have megajoules, which is represented by the symbol capital M capital J, and it is equal to 10 to the power 6 times of joules. So this is all about energy, and in our next module we are going to discuss about the different forms of energy.